So what are exponents? Exponents are simply a concise way of writing an expression where you have a term multiplied to itself a certain number of times. For instance, let's just say we have the number 2. And if I multiply the number 2 to itself 6 times, I have to write it out in a very lengthy form. But I can write it as, sorry, not 5, 6. I could write it this way in a very compact notation, 2 raised 6. So where does that 6 come from? I have 2 times 2 times 2 times 2 times 2 and times 2. So I have 6 of them. So we would have 2 raised 6. What if I change 2 to some number? And let's say I have m times m times m times m times m times m. Then I will have m raised 6. I could also have other types of exponents. I could say x plus y times 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 x plus y. That would give us x plus y raised 6. So exponents come into play anytime you multiply a number or a term to itself over and over again. So we like to call that as the base and that as the power. So the base would be x plus y, the power is 6. In the previous case, the base is m, the power is 6. Here the base is 2 and the power is 6. If we want to deal with exponents, we have to know some properties that are quite important in terms of simplification. So I'm going to write those rules. The very first rule for any number a not equal to 0, a raised 0 would be equal to 1. So if you take a number and raise it to the power of 0, you would end up getting 1. I'll take this back for any number a. 2. If we have a raised m times a raised n, note the bases are identical, but the powers are different. So in this case, we can write the common base a and combine the powers as m plus n. And that is what we call the product rule. The next case is a raised m divided by a raised n. The bases are identical. The powers are different. So one is m, the other is n. So that would equal to a raised m minus n. That's quotient rule. Let me write an example on the side so that you kind of connect the dots right away. So if I have 4 raised 3 multiplied by 4 raised 5, I have identical bases, which is 4, different powers. One is 3, the other is 5. I can add it. 4 raised 8. Quotient rule. If I have 4 raised 5 divided by 4 raised 3, I would have 4 raised 5 times 4. Oops, let me not do it that way. 4 raised 5 minus 3, I get 4 squared. Suppose we have a single base and it is raised to the power of m, and we take the entire term and raise to the power of n, then I could write it as a raised m times n. That is what we call the power rule. For instance, suppose I have 2 raised 3, and I raise it to the power of 2, then I would put the base 2, and I am going to multiply the 3 and the 2 to get 6. So common mistake, people tend to add, but in reality, we've got to multiply. If we have 1 over a raised m, m is a positive exponent. Well, this entire expression is a positive exponent, and I can turn it into a negative exponent. So if a raised m moves to the numerator, you will get a raised negative m. For example, if I have 1 over 8, the power of 8 here is 1. So if I move it to the numerator, I can write it as 8 raised negative 1. In a similar manner, if I have a raised m and I wanted some negativity here, I could rewrite a raised m as a raised m divided by 1, and I can move that to the denominator, and it would become 1 over a raised negative m. For example, if I have 2 raised 4, I can write it as 2 raised 4 divided by 1. They are one and the same. And if I move that to the denominator, I would have 1 over 2 raised negative 4. Then lastly, that's called the nth root. We will see this later on, but I think this is a good place for us to write it. Just like the square root, we have the cube root, the 4th root, the 5th root, and so on. So this is the nth root. I can write the nth root as a raised 1 over n. They are one and the same. So if we have the nth root, that simply equates to putting a and raising it to the power of 1 over n. So here we are going to do a few examples where we want to take an exponent and express it, or an expression that contains exponents, and express it only in terms of positive exponents. What do I mean by that? So here is the first example. 5x raised negative 3 times y raised negative 4. 5 is a constant, so I can leave it as is. I can rewrite this as x raised negative 3 over 1, y raised negative 4 over 1. Mind you, I'm doing this extra step so that you can understand. Once you have good practice, you don't have to do this intermediate step. You know, it'll come natural to you. So if x raised negative 3 moves to the denominator, I'll have 1 over x raised 3. If y raised negative 4 moves to the denominator, I'll have 1 over y raised 4. So we will have 5 divided by x cubed y raised 4. So here is another example. Let's say I have a raised minus 7 divided by, b raised minus 5. Both the numerator and the denominator have negative exponents. So I want to make them positive. So first, I'm going to move the a raised negative 7 to the denominator, which would give us a raised positive 7 multiplied by b raised negative 5. Then I could move b raised negative 5 to the numerator. I would have b raised 5 divided by a raised 7. And now I have terms with only positive exponents. So we have a raised 4, b raised negative 2, c raised negative 5. So a raised 4 divided by 1, b raised negative 2 divided by 1, c raised negative 5 divided by 1. So a raised 4 is a positive exponent, so I would leave it as is. b raised negative 2, I can move it to the denominator. I'll have a raised negative 5. Well, let me not write it, that might be confusing. So a raised 4 divided by 1 multiplied by 1 over b squared multiplied by move c raised negative 5 to the denominator, we get c raised positive 5. So we will have a raised 4 divided by b squared, c raised positive 5. Okay, so this is the intermediate step that I'm going to do so that you understand. But as I mentioned earlier, once you get good practice, you don't have to do this step. So I'm going to leave a raised 4 as is because it has a positive exponent. Going to move c raised negative 3 to the numerator. I have a raised 4 multiplied by c cubed. Move b raised 3 to the denominator. We have b raised 3 d squared. So we will have a Can you hear me now? Okay. So let's say we have 16a raised 5b divided by a squared b squared. And let's try to write the answer using positive exponents. So the easier way to do this, because we're simplifying using quotient rule, first we just have to group all like terms, keep numbers on one side, combine the a terms, combine the b terms. So 16 over 1, a raised 5 over a squared, b over b squared. We have b, which is equivalent to saying b raised to the power of 1. So we will have 16. Quotient rule states if the bases are identical, we subtract the denominator power from the numerator power. So a raised 5 minus 2. Same applies to b, numerator power minus denominator power. So 5 minus 2 is 3. 1 minus 2 is negative 1. But as I mentioned in the beginning, I said it's best to have the answer in positive exponents. So this could be written as 16a cubed b raised negative 1 divided by 1. Move that to the denominator. We will have 16a cubed divided by b. Suppose we have 28a raised 5 b squared c divided by a raised 4 b cubed c squared. The process is exactly the same, even though it looks like a complicated expression. The underlying process does not change. So the number, I'm going to write it as 28 over 1. Going to group the a terms, a raised 5 over a raised 4. Group the b terms, b squared over b cubed. Group the c terms, c over c squared. So 28 over 1. The bases are identical, which is a. Subtract the denominator power from the numerator power. So we will have 5 minus 4. Do the same with b. Numerator power is 2. Subtract the denominator power, which is 3. Do the same with c. The numerator power is 1. Subtract the denominator power, which is negative 2. 28, a raised 5 minus 4 is 1. B raised 2 minus 3 is minus 1. C raised 1 minus 2 is minus 1. And I said, would like to have positive exponents just for practice. So I can write 28 times a times b raised 1 times c raised negative 1 as 28a times b raised negative 1 times c raised negative 1 over 1. So I could move that to the denominator, which would give us 28a. If b raised negative 1 moves to the denominator, it becomes b raised positive 1. If c raised negative 1 moves to the denominator, it becomes c raised positive 1. So we would end up having 28a divided by b times c. So 14 divided by 1, group the a terms, a raised 5 over a. Group the b terms, b over b raised 5. Move, since a has identical bases in the numerator as well as the denominator, a numerator power minus denominator power, b numerator power minus denominator power. So we would have 14, a raised 5 minus 1 is 4, b raised 1 minus 5 is minus 4. And since I wanted in positive powers, I can rewrite that as 14 a raised 4 multiplied by b raised negative 4 over 1. Move that to the denominator, it becomes b raised positive 4. So 32 over 1, group the t terms, t squared over t, r raised 4 over r squared, s raised 8 over s raised 6, 32t, numerator power minus denominator power, because t has identical bases, same with r, numerator power minus denominator power, same with x, numerator power minus denominator power. So we would end up having 32t, r raised 4 minus 2 is 2, s raised 8 minus 6 is 2. So we would end up getting 32t times r squared times s squared. So we are going to do a few examples where we will combine product rule and power rule and quotient rule to see if we can simplify an expression. So 16 s squared multiplied by r divided by s squared raised 2 multiplied by s squared. So the process is pretty much the same in the sense that we want to group all the terms that involve t together, terms that involve s together, terms that involve r together, and keep the number as is. So 16 over 1 times t raised 5 over 1 times s squared over s squared squared times s squared multiplied by r over 1. In a problem like this, one would naturally want to use both power and multiplication rule or product rule. But before we do that, we can see that we have identical terms in the numerator and the denominator, which is s squared, so we can directly cancel them. You should always think about canceling common terms prior to doing further simplification. So that's exactly what I did. So 16 over 1, t raised 5 over 1. And now we could use power rule. since we have s squared raised to the power of 2, we simply multiply the powers. 2 times 2 is 4, multiplied by r over 1. So if we combine everything, we will get 16 t raised 5 r divided by s raised 4. So here we don't need product rule at all. So let's just split the terms. 2 over 1, a squared over a, b cubed raised negative 2 over b squared, 1 over c raised negative 4. 2, a numerator power minus the denominator power, 2 minus 1. 3 times negative 2 is negative 6 over b squared, multiplied by 1 over c raised negative 4. So 2a, b raised negative 6, negative 2, numerator power minus denominator power. And we can move that to the numerator and write it as c over 4. So 2a, b raised negative 8, c raised 4. Move that to the denominator, we will have 2a c raised 4 over b raised 8. So we can write this as 2 raised negative 4 over 1, a raised 2 cubed times a raised negative 2 over 1, 1 over b cubed, b raised negative 2 squared. Keep in mind, I am trying to group all the terms, identical terms together. So we will have 2 raised negative 4 over 1, power rule, a raised 2 times 3, 6, a raised negative 2 over 4, 1 over b raised 3, b raised negative 2 times 2 is negative 4. So 2 raised 4, a raised 6 times a raised negative 2. The bases are identical, so we combine the powers, we add them, so we have 6 minus 2. In the denominator, I'm multiplying the b's, so b raised 3 minus 4, because the product rule states if the bases are identical, you add the powers. So we will get 16, a raised positive 4, multiplied by 1 over b raised 3 minus 4, which is negative 1. If we move b raised negative 1 to the numerator, we will have b raised positive 1. So the answer is 16 a raised 4b. This expression that we have is simple, even though it looks kind of weird. So even before you start, first thing to say, ask yourself is, could I cancel some terms? If you look at the expression, there is a u there, another one there. So I can cancel them first, then proceed to simplifying. If I move the 3 raised negative 1 to the numerator, it would become 3. So we will have u raised 2 raised negative 2 v squared over v squared raised negative 1. 2 times negative 2 is negative 4 v squared over v raised negative 2. When I move v raised negative 2 to the numerator, I am going to subtract the powers. So 3 u raised negative 4 multiplied by v raised 2 minus of minus 2, because I have to subtract the powers, or moving it to the numerator and using the quotient rule are one and the same. So 3 u raised negative 4 v raised negative 2 would become positive 2, and 2 plus 2 is 4. Last step, I'm going to move that u raised negative 4 to the denominator. So 3 v raised 4 over u raised 4. So here we have, an exponent that is sort of complicated looking. So where was I? So if we have an expression of this sort, the very first thing to do is to take care of whatever terms that are inside the parentheses. May it be cancelling, may it be the use of product rule, may it be the use of quotient rule, doesn't matter. So anytime we have terms inside the parentheses, take care of the inside before we apply stuff to the outside. Now, here are certain rules that I would like to write prior to moving. So if I have 2 different bases, x times y, but I use the same power, m. So here I have x, and then I have y, but the power is just m. And that is common to x and y. So I can write this as x raised m times y raised m. So if the bases are different, but you have identical powers, you combine the bases and raise it to that one power that you have. Same applies to x over y raised m. So the bases are different. The power is just m. So I could apply m to the numerator and m to the denominator. So I took the identical power and distributed it to the numerator as well as the denominator, recognizing the fact that the numerator base is different from the denominator base. Okay, this is something that we need. So in this problem, well, I said, okay, first thing to do is take care of whatever that is inside the parentheses. So let's take care of that. If x raised negative 3 moves to the denominator, it becomes positive 3. And if y raised negative 3 moves to the numerator, it becomes positive y cubed. Now, this would use the property that is right here. So we have two different terms in the numerator and the denominator, but we have one identical power, so I can distribute that -2 to both the numerator and the denominator. So you have y raised 2, 3 times -2. So I'm multiplying those two and do the same. Well, I don't want to confuse, so let me just not skip that intermediate step. So the identical power that we have is -2. I can apply that to the numerator and also the denominator. So y cubed raised -2 divided by x cubed raised -2. So instead of x and y raised m, I have y cubed raised -2, x cubed raised -2. And now we could use the standard power rule. 3 times -2, -6. 3 times -2, -6 in the denominator. But we want the answer only in positive exponents. So I move x raised -6 to the numerator, y raised -6 to the denominator. So I will get x raised 6 over y raised 6. So here is another example. So again, we want to take care of the term that is inside the parentheses before we tackle the power that's outside the parentheses. So group all the x terms. And we are doing it this way because, or I am doing this way because you guys are still learning. But with practice, you don't have to go through all these steps. If you practice well enough, it'll come naturally to you. So 2 over 1, I can leave it as is. I can move the x raised -2 to the denominator. That would become x raised 2 times x raised 3. Move y raised -2 to the numerator. I'll have y times y raised +2. So 2 multiplied by 1 over identical bases, which is x. So add the powers, 2 plus 3 is 5. The next term, y and y, identical bases. So add the powers, 1 plus 2, we get 3. So inside the parentheses, we have 2y cubed divided by x raised 5, the entire thing squared. Now we can apply the power that is outside. So 2y cubed raised 2 divided by x raised 5 over, over x raised 5 raised to the power of 2. We can multiply those two and those two. So we get, and also, let me not forget, 2 would mean 2 raised 1. So we should also multiply 1 and 2. So 2 squared, y raised 6 over x raised 10, which is 4y raised 6 divided by x raised 10. So let's simplify, and we want the answer only in positive exponents. The first thing to do, if there is confusion, we split the terms. In the sense, keep all the y's together, the x's together, numbers together, a's together. So 1 over a raised -2, entire thing raised -3. Now, if you split this way, the confusion wouldn't happen on how to combine the y's or how to combine the x's and so forth. As I mentioned earlier, if you take care of the inside, and if you take the approach that I'm doing right now for a couple of problems, once you get good practice, it will come naturally to you. So going to have x raised -cube over 1, y -1, y raised -1 divided by y raised -2, numerator minus of minus denominator power. I can move. Now this problem is sort of weird because I have a negative and then I have a negative outside. So let's just stick to the usual process and see what happens. Of course, there are other ways to do this. So if I move that to the numerator, I'll get a squared. So x raised -3, y raised -1, and -2, or minus of -2, I'll get +1 and a raised 2. We have 3 different terms, but under the same power, which is -3. So we can apply that -3 to each of those terms. So x raised -3 raised -3, y raised 1 raised -3, a squared raised -3. X raised -3 times -3 is x raised 6. Y raised 1 times -3 is y raised -3. A raised 2 times -3 is a raised -6. So we have x raised 6, y raised -3 in the numerator, so I can move to the denominator. A raised -6 in the numerator, move to the denominator. So we have y cubed, a raised +6. Yes, that is x raised 9, bad algebra. So if we take the problem and pursue with these intermediate steps, 1 over there and 1 over here, you will do the problem without making mistakes. Of course, there are other mistakes that are possible, but at least we can limit the number of mistakes.